Hello, and welcome to Totally Tech Tom. In this episode, I'm going to take you through the resources required to deploy a VPC in AWS using Terraform. This is a follow-on from a previous video where I talked about resource blocks. I thought it would be a good idea to build on the concepts from the previous video by building up a root module that we can use in future videos. Also, stay tuned to the end of this where I will talk about a useful process that you can use when working with Terraform within an organization. So let's take a look at what we're going to do today. This is what we built in the last video. Right now, there is no route out to the public internet. If I put an EC2 instance here, there'll be no way for it to make its way out here by default. So what we're going to do today is we're going to connect that up by introducing an internet gateway, a route table resource that will have a default route set to that internet gateway, create an EC2 instance, and then it will use the route table of this subnet and go out onto the public internet. And because of that functionality, it turns this subnet now into a public subnet, because the definition of a public subnet in AWS is that it is directly connected to an internet gateway. So let's make a start. First off, I'm going to create this internet gateway resource. Now, I've gone ahead and I've made a copy of the resources folder from last week, and I've applied the Terraform. So now we have the tutorial VPC and the subnet that we created in the last video. So what I'm going to do now is open that vpc.tf file again and start by creating a resource, an AWS Internet Gateway resource. And this takes the argument of a VPC ID, which we're going to grab again from the attributes, and then just keeping things the same, I'm going to give it a name tag and just call it tutorial, like that. Simple. Now I'm going to create a AWS route table. So I'll do resource AWS route table. Again, this needs the VPC ID, so just grab that from the attributes. And I'm going to create a route like this. It's going to have a CIDR, which is just any, because it's the default route. And then give it a gateway ID, which is the internet gateway.tutorial.id, the one that we're going to create shortly, this one up here. Okay, and then just add some tags again to that. Name equals tutorial. And now, so carrying on, we now need to do a resource for an AWS route table association. And this is to attach it to our subnet. So it takes the subnet ID as an argument. So we'll grab the subnet ID from its attribute, and also the route table ID. So we'll grab the route table ID of its attribute. And that's it. So we've created, let's go back to our diagram. We've created the internet gateway, a route table, and we've associated that route table with our subnet. So we now have the building blocks of a VPC that can be used for hosting EC2 instances to access the internet. But I just want to make our EC2 configuration a little bit easier. So what I'll do is enable a flag on the subnet called map public IP on launch. I'm going to set that to true. So by setting this flag to true, what that means now is when we create an EC2 instance, it'll automatically give us a public IPv4 address. And because our subnet is now a public subnet, it is common practice to name them as such to make it clearer for the intended purpose. So let's just add that in, public tutorial, like so. And I'll just do the same with the root table as well. Just call that public tutorial. So you can see it's the public root table, which is associated with the public subnet. Let's apply that then now, shall we? Yep, so in the plan, we've got our internet gateway being created, associated with our VPC, a root table, again, associated with our VPC. It's got our roots here for the default root, and then a root table association with our subnet that we created earlier. And then just our changes to that subnet to make it clear that it's a public subnet. So I will apply those now. Cool. And quickly, I'll just show what we've done. We have our internet gateway associated with our tutorial VPC. We have our public tutorial root table. Now, because we've associated this with the VPC, it gets that local root by default. That's the VPC CIDR. And then we've added this additional root, which uses the internet gateway for the default destination. And then lastly, our renamed public tutorial subnet has that root table associated with it. So now we have a route out to the internet. Right. So now that we've done that, let's create an EC2 instance. I'm going to start off by creating this security group, and then I'll create an EC2 instance, which we can attach that security group to. So, in the spirit of keeping file names appropriate to the resources it contains, let's create a new file called ec2.tf. And inside, we're going to create the resource AWS security group, like so. So this security group, it acts like an access control list, inbound and outbound of our EC2 instance. So if we don't define one, what we'll end up with is the default security group, which was created when we created the VPC. And that default security group will block all inbound traffic by default unless you specify additional rules. Now, I would actually say avoid changing the default security group in any way, because if you accidentally forget to define a security group on any resources, you could end up accidentally poking holes into your network. Back to the security group, it needs a VPC ID, which again, we can just grab from our attributes of the security group we created, and then a name, which we'll just call tutorial original, and then a description which will help others understand the intention of the security group. So in this case, I'll just put allow SSH inbound traffic to the tutorial instance. Okay. Now we'll give it an ingress block. We'll do from port 22 to port 22 on TCP protocol with a CIDR block. And I'm just going to allow any traffic inbound. I'm going to create an egress rule now. And this one is just to allow all traffic out, because when we create a security group with Terraform, it has no outbound rules, which the default is to deny, so we won't be able to access the internet without this. -1 is just to say any protocol is allowed. And again, we'll give it the any IP address, any CIDR block, just to allow access out. And give it our super cool tags tutorial. Now, in a production environment, you would obviously want to restrict outbound traffic to whatever it needs. But in our case, it's just to show you how it works. Right, and lastly, we'll create the instance. So another resource, AWS instance resource, tutorial. The first argument is the AMI. The AMI is an image that it uses to start the instance with, like Linux or Windows or something like that. You can grab that from the EC2 console menu, the AMI catalog. We'll just grab that. That's the AMI ID. Now, there are better ways of getting the AMI ID with Terraform, but I'm not going to go into them right now. But if you want to have a look into it, it's called a data lookup. Instance type, just give it instance type T2 micro, because if you've got a brand new account, the T2 micro is free for up to 750 hours per month. So is enough for you to do some basic testing. We need to put it in a subnet, so we'll grab the subnet ID argument. And then we need to give it a security group. So let's do VPC security group IDs. And then we'll grab that security group. Now, this is wrapped in square brackets because it's a list item. And I haven't really spoke about lists yet, but it just means you can have multiple security group IDs inside these square brackets. And if you're familiar with other programming languages, you probably already get what's going to happen here is it's a comma-separated list of strings. So you could also have the security group ID in plain text that you could just add in yourself there like that. Anyway, we've just got the one output attribute from the security group we're creating, so we'll just do that. And then tags, again, name equals tutorial. Why is it underlined red? Something's not right. Because it needs to be tags. Right, cool. Let's run Terraform apply then. Just to go through the plan quick. We've got our EC2 instance. We've got the AMI ID we've selected. Our instance type. A lot of things, a lot of arguments are just known after apply here because there are a lot of arguments you can specify on this resource type. But we've got our subnet, and somewhere we've got our security group, security groups. But we won't see them because our security group hasn't been created yet. So here's the security group. We've got an egress rule of anything out. And then we've got an ingress rule with the inbound on port 22 from any IP. So let's apply that. And very quickly now, we can go to instances from the EC2 console menu. And we can see our tutorial instance is now running. Very quickly starts up. It's got a public IPv4 address, the private one. The VPC, which is the tutorial one, the subnet, public tutorial. You can see the AMI ID. There's all kinds of information here. I'm not going to go through it all. Just showing you where we've specified some things, and you can see that it's all connected up in the way that we wanted from this diagram earlier on. Quickly now, we can just click on connect. Connect using EC2 instance connect. We've got the EC2 user. Everything's all set up. Default, just click connect. Ta-da! And just to show you, we can ping google.co.uk. So there's our outbound connectivity. Well, that about wraps it up for today. Just going back to the thing that I promised at the end. This is the administrative task that will help you in a organization if you're using Terraform. And that is just to keep your Terraform providers and Terraform itself up to date with current releases. So new versions are released all the time. You see, the providers move on to support changes with the APIs. And as new features come out in the cloud, they introduce breaking changes. And if you don't keep up to date with that, when you come to update your provider in the future for whatever reason, you end up with lots of little things that you need to fix to make your code work again. So you're just keeping on top of things and saving yourself the effort later on. It's a good thing to get yourself into a routine with. So how do you do that? So with Terraform, I use something called TFenv, and I've created a video on how to install that already. So check up above. I'll link that to put a link in for that. So right now I'm using Terraform version 1.10.1. Okay, and if we check out TFenv list remote, just scroll up. The latest is actually 1.10.3. So because we've got TFenv, we can just go into this file within our root module called .terraform-version, change that version to 1.10.3, and then simply run terraform apply. And it will automatically install the latest version the next time the Terraform binaries hit. You can see now that it's switched to Terraform 1.10.3. When I ran apply, we had no changes. So that means everything's great. We just carry on as normal. And what that'll have done is updated our Terraform version inside the TF state file, which will restrict anybody who is using an older version of Terraform from being able to run apply against this root module. But of course, if they're all using Terraform TFenv as well, then they'll just install the latest version as soon as they come to apply it anyway. So that's Terraform. The next one is the provider. So we have the Terraform lock HCL file, which currently says it's the AWS version is 5.80.0. And if we look, 5.82.2 is now the latest version. So because of the way the provider's defined, it's saying match on version 5, but fuzzy, it doesn't matter about the minor version because of this caret greater than symbol. So if we do a terraform init -upgrade on the CLI now, it'll reinitialize everything, but it will also update this provider version to whatever the latest is. Unless it was version 6, and then it would avoid that because that doesn't match the version constraint. It has to be anything within version 5. Cool. So we've done that, and now our Terraform lock HCL file reflects the changes we've just made. And if we do a quick plan, no changes. The goal is to always have no changes in your plans because that says that nothing's broken in the update to your provider or Terraform. Okay, so before we leave off, let's make sure we destroy all of our resources. Particularly now, because we've got an EC2 instance in there and it's a billable item, we don't want to leave that running and incurring costs. Okay, well, thanks for watching. I hope you found that useful. I am making another video about variables, which is going to follow on from this one. If you are enjoying my videos, please support my channel by subscribing and giving me a like. As always, if you have any questions, comments, leave them in the comment section below. Feel free to leave me some feedback in there if you can. Like I said, I'm currently working on another video about variables, which is what led me to creating this, to be honest, because I thought, do you know what? I need some more resources to work with in the variables discussion to make the usefulness of variables more clear when building out our Terraform configuration. So until that drops, see you next time, and happy coding.